Talking about this pyramid and its counterpart, the components, I will I will talk more about the components that we deliver to the countries. Each component have a triad of, well, three items. In each component, we have the software and its code in a repository that it's open and available to look and implement. And we will look at the end of the slide. We also have the documentation of use and administration, but one of the things that we do was write this in Spanish because it's Latin American countries, and all of those platforms, all of those open source software had maybe a lot of documentation, but it lacks of Spanish translations or, well, yeah, any other kind of language that it's not English. So in a part of this project, we took that documentation, we enhanced that documentation itself, and we translated it into Spanish. And well, the third item is the methodological guide, where we talk about how to use it and some best practices in order to use all of these components. Well, one of the needs here was the activity of field collection. In this scenario, we proposed and implemented Kobo Toolbox. I don't know if all of you know this platform, but basically, Kobo Toolbox is a powerful and intuitive data collection tool, which has a lot of features. One of the main features are, well, it's super powerful form development. In Kobo Toolbox, you can build your form, build your questionnaire super easy. You have the questions, you have the question types, you have the titles, you have the answers, and you put all of this together and you have a super rich form. Another good thing that it has is a data collection and analysis. It's also a Android application, for example, or a web application that you can complete all of those forms and visualize and do the analysis of those that data collection that you made earlier. Also, Kobo Toolbox is made for challenging settings. It's made for field data collection, so it works offline, it works in any device, and well, one of the main things is that it works offline. So you can go to the field, you don't need super Wi-Fi connection, super rapid internet connection. You can complete the forms, send to them, and when you get connection, the service are sent to the server. Well, another need was the need of geocoding. We implemented Nominatim that uses OpenStreetMap data to find locations and by name and address, geocoding. And also it has reverse geocoding if you have some point and it gives you the address, the complete address. Well, Nominatim by itself, it exists, it's implemented, but one of the main features that we made was working with the country's data that was not public, was not in OSM, and was very informal, like some streets that were unknown. So in order to upload it to Nominatim, it was hard work to normalize and work with the data in able to be able to upload it to Nominatim and use it. Well, another component is the Statistical Data Manager. This is a custom development. All of these components are mixed. We have some software, open source software that exists, and we have some components that we made. All of these are in the repository, in the GitHub, that we will show at the end of the slides. Well, this was a custom development that allows us to fill all of the information that it's above, like in custom made by for each country. Well, in the Geospatial Data Manager, basically GeoNode, we use GeoNode. I think it's the main component here because it proposes a way to manage your information and make available. So it was super hard and challenging task to do, was talking with the countries. Let's see how you have the data. Well, some countries have super salad mix of data, super in super disorder. That's why one of the hardest thing to do was work with the data and make it available to put it in GeoNode, for example, and build a SDI for these countries. Well, in terms of metadata, we proposed GeoNetwork. GeoNetwork is a catalog application to manage spatially referenced resources. It's compatible with most standards. It's compatible with OGZ, SDMX, ISO 19100. On the other hand, we have, data as a service. We built, this is also a development of ourselves. We made an API to interact between regional actors. The idea of this component is to make available all the information built by the data integration process and being able to, the end user, every one of us, being able to interact with those data, with API calls or anything. Well, in terms of visualizations, basically the way to look those data with our eyes, we used Metabase. Metabase is a framework of visualizations that has a super friendly UX and it's super easy to use. And it has integrated tools to query your data, to make visualizations, and to make available all of these viewers. So we have also the data bank. Basically, it's also a custom development. It has Python in the backend and React in the front end. The main feature of this component is to show multidimensional data. It's made with React, and it has super interactive tools to play with dimensions of the data and a way to show and explore data cubes. We have also, this is the Geoportal. It's wrong here, it's not Geocoder. Don't look at it. This is a super useful and friendly map viewer. It's custom made with all of the other components. The idea of the map viewer is to use, geospatial data that you made available, the statistical data, and cross them and show them in a map viewer. Here in the that data orchestrator, we are using Airflow to communicate like some kind of wide communication between components. In this step, we basically make the communication of those components individually to, integrate them and validate all of the workflows. In the other hand, we have some vertical process that it's the data integration processes. We proposed Python. We ended up using Airflow too, because it's a super powerful platform to make, for example, ETLs. In this step, the idea of this step is the integration of all the information that has each country, maybe in some database in Postgres, Oracle, any kind of data that they have outside of this ecosystem. The idea of this component was to integrate all the information with all of our components. Well, and all of those components are available in the git.cepal.org/geo. We have some components that maybe it's a fork from the open source solution, and we have another components that are developed by ourselves. Okay, looking about the results. The components may or not been implemented. We had a lot of problems about the architecture and this availability of like the servers and the hardware. So not all of the countries were able to implement it. For example, using PostgreSQL, and it's super integrable. It's super joinable with our solutions because we use Postgres in in a lot of components. So it's basically, well, okay, you have Postgres, let's install our database there. And it was super, super easy to connect. Well, we needed to develop other components. We didn't find some open source solutions that ensure us all of the requirements that we had. So we needed to develop the components that I said earlier. And the main idea of this project is to activate some kind of community between the countries, because they all have the same components. We made a forum that had a lot of activities, and the countries were talking. It was super cool, but because they were talking by themselves, like, hey, I have a problem when I develop GeoNode, I can't, I don't know, upload a layer. So there goes another country that had the same issue, and they solved it, and say, okay, let's try this. And they were helping each other. That was the main idea, and it was accomplished. And one of the main things that we helped fulfill the 5 principles of the global statistical and geospatial framework with all of these components.